Hey everyone, and welcome to today's Explainer. Today, we're diving into something super foundational. Sometimes the absolute most fascinating scientific puzzles aren't buried in giant, dense textbooks. They're actually hiding in really brief, punchy little prompts. So let's break down Activity 1.2. It's this tiny snippet of text that actually holds a completely captivating scientific mystery.
Okay, let's dive into this. Have you ever looked at a deceptively simple set of lab instructions and just felt that, undeniable spark of curiosity? Well, that is exactly what we're dealing with right here. On the surface, it's just a few words, a remarkably simple prompt. But underneath all that simplicity, it's this incredibly intriguing question just waiting to be unraveled by our own observation. In this explainer, we aren't just going to sit here and read words on a page. No way. We're stepping directly into the mindset of an active scientist.
Take a look at the foundational text of Activity 1.2. Notice how incredibly brief this thing is? It's definitely not giving us long, rambling paragraphs of background theory. Actually, it's giving us exactly 3 distinct bullet points: a setup, an action, and a question. That is literally the entirety of the text. But hey, we're not just going to skim past this. We are going to meticulously unpack every single one of these 3 bullets to figure out exactly what this elegant little experiment is asking us to do and, why it's structured this way in the first place.
All right, phase 1, the setup, establishing the baseline. Now, what's really interesting about this is how it isolates the very first chemical ingredient. When you're in a lab setting, you can't just rush in like a bull in a china shop and start throwing random things together, right? You absolutely have to establish a baseline and carefully prep your environment before any kind of reaction can happen. Notice the super specific language it uses to introduce our first component. Take lead nitrate solution. Boom. No lengthy, boring history of how it was discovered. It just simply isolates the specific ingredient, lead nitrate, in solution form as the critical starting point. It's the foundation of the whole shebang.
And check out how highly specific the text gets about the environment. In a test tube. This provides our physical baseline. We're isolating that lead nitrate so that whatever happens next is going to occur in a perfectly controlled, totally observable arena. Moving right along to phase 2, the catalyst, introducing a variable.
And enter ingredient number 2, potassium iodide solution. Just think about the sheer narrative anticipation building here in just a handful of words. On one hand, you've got the lead nitrate just sitting there, waiting patiently in the test tube, and on the other hand, you're now instructed to hold this potassium iodide solution. These are 2 completely distinct elements, right? They're totally separate and perfectly stable on their own. But the instructions are building up to a climax. They are about to force these 2 completely distinct worlds to collide.
Let's move to and see how this builds. Step 1, take the lead nitrate solution. Step 2, add potassium iodide solution to this. Really notice that active verb, add. The text is literally commanding you to break the isolation of that first ingredient. It's an instruction of pure action. It's taking us all the way from a passive, quiet setup straight into active, hands-on experimentation. So, the crucial point is, right in that fraction of a second before the pour, we have 2 entirely distinct solutions, right? Solution 1, lead nitrate. Solution 2, potassium iodide. The text explicitly tells us what we're combining, making sure we know the exact variables going into that tiny test tube. But pay really close attention to what the text does not tell us. Think about it. It gives us the actors. It completely sets the stage. It basically yells action, but then it just completely refuses to give away the ending.
Which brings us to phase 3, the unknown, the missing ending.
And this brilliantly illustrates the true nature of scientific inquiry. What do you observe? Man, this completely flips the script on us. Suddenly, the text is no longer this bossy authority figure just handing you instructions. It literally becomes the questioner. It places the entire weight, the whole responsibility of the experiment, directly onto your shoulders. It demands that you stop reading, look up, and start actually looking. You have to rely entirely on your own perception, your own 2 eyes, to document the reality of the chemical reaction that is unfolding inside that glass tube. Because at the end of the day, the ultimate question isn't what some dusty textbook says should happen. The real question is, what do you observe? By stopping right at the exact moment of physical interaction, Activity 1.2 forces you to pay close attention. Like, does the liquid suddenly change color? Is there a gas being produced? Does some weird solid form out of nowhere? It leaves us completely dependent on our own active discovery. Well, thank you so much for joining me on this explainer. I really hope this leaves you hanging on the edge of your seat, absolutely eager to get in the lab and find out exactly what happens next.